एनर्जी बैंड्स ऑफ मेटल, इंसुलेटर एंड सेमीकंडक्टर। हमें इन तीनों के एनर्जी बैंड डायग्राम बनाने हैं। सबसे पहले हम लोग मेटल या कंडक्टर के बनाते हैं। इन द मेटल और कंडक्टर, वैलेंस बैंड एंड कंडक्शन बैंड ऑलवेज ओवरलैप ईच अदर। Means at 0 Kelvin the situation is also like this. This is the, you can say, the valence band. This is the top layer of the valence band. It is known as the EV. This is the conduction band, like this. This is the bottom of the energy level of the conduction band. It is known as the EC. So I say this is known as the conduction band. This is known as valence band. And here we observe that both conduction band and valence band overlap like this. So here we will write, due to overlap of valence band and conduction band, electrons from valence band can easily move to conduction band. So here large number of electrons are available for conduction. ये किसके लिए एक्सप्लेन कर दिया आपने? ये आपने मेटल के लिए एक्सप्लेन कर दिया। तो मेटल में आपको क्या समझाना है एग्जाम में? कंडक्शन बैंड एंड वैलेंस बैंड दोनों ओवरलैप करते हैं, और 0 केल्विन ऑल्सो the electrons are easily available to move in the conduction band, so their conductivity is high. तो इसको हम लोग नेम कर देते हैं, this is for conductor oblique metal. अब हम लोग इंसुलेटर का बनाते हैं। इंसुलेटर के अंदर there is a forbidden gap between the valence band and conduction band, so we will say this is the situation for the valence band. This is the top of the valence band, that is known as the EV. This is the conduction band. This is the bottom of the conduction band. It is written by EC. So again, it is known as the valence band. It is known as the conduction band. And there is the energy gap between the valence band and conduction band. This energy gap is greater than 3 electron volt. So this is the situation for insulator. So what we will say here, a large energy gap that is Eg is greater than 3 electron volt between valence band and conduction band. There are no electron in conduction band. Means here we will say electrons are available in the valence band but no electron in the conduction band. So here this conduction band is empty, or you can say it is empty conduction band. Here you will say here energy gap, that is Eg, between valence band and conduction band is high, is so large that electrons cannot be excited from valence band to conduction band by thermal excitation. तो ये किसका केस हो गया? आपका इंसुलेटर का केस हो गया। Then next we will explain for the semiconductor. Semiconductor में again there is energy gap, but this energy gap is less than insulator. So this is the valence band and this is the conduction band. This you will write, it is known as the EV. This is known as the EC, and this energy gap is less than 3 electron volt. It is less than 3 electron volt. This is the diagram for semiconductor. This is the explanation for semiconductor. Again, here are the some electrons in the valence band. अब रूम टेम्परेचर पे इनको इतनी एनर्जी मिल जाती है कि इलेक्ट्रॉन इजीली वैलेंस बैंड से कंडक्शन बैंड में जंप कर जाते हैं, क्योंकि एनर्जी गैप इज लेस देन 3 इलेक्ट्रॉन वोल्ट. सो यू विल राइट a small energy gap that is less than 3 electron volt between valence band and conduction band. So at room temperature at room temperature, some electrons from the valence band jump into the conduction band by acquiring the energy. Some electron may jump from valence band to conduction band. So we can say resistance of the semiconductor is less than insulator. आप लोग लर्न कर सकते हैं जर्मेनियम के लिए एनर्जी गैप कितना होता है 0.72 इलेक्ट्रॉन वोल्ट और सिलिकॉन के लिए एनर्जी गैप कितना होता है 1.1 इलेक्ट्रॉन वोल्ट. कार्बन के लिए एनर्जी गैप कितना होता है इट इज गिवन बाय 5.4 इलेक्ट्रॉन वोल्ट. So this is the explanation for the energy band of the metal, insulator and semiconductor.